Alright YouTube, hello, thank you for watching. I'm going to do something a bit different today. I'm going to go back to about 2 or 3 years ago when I did some videos on a Sansui integrated A-40. This was built in 1980. A viewer has one of these and has some issues, so I'm going to see if I can't help him out getting this little A-40 to run. And my lighting is pretty poor. Or, well, I don't want to say it's pretty poor. I think my lighting is substandard. Let's just put it that way. Man, they're super simple. It literally took nothing to get that cover off of there. It's going to take a while for things to come back to me. But I do remember when I opened this unit up for the very first time, I saw these resistors kludged across the board here. I thought, who in the hell put resistors in here that don't belong there? And it's kind of funny because my first inkling was to take them out of there. I think that maybe what has happened there, that somebody saw these and said, hey, they're not supposed to be in there, because it's pretty unusual to open an amp like this and see a manufacturer do stuff like this. Now, all this other crazy stuff was stuff that I did, but these were factory. And what kind of gave it away that this was factory within probably 5 minutes of looking at this was the leads were crimped on them. And I saw that they looked like they were the same metal oxide resistors that Sansui typically uses, because I had a lot of Sansuis under my belt prior to opening this. I told this guy these were 100 to 220 ohm resistors from memory. So there's a 220, a 220, a 220, a 220, and a 100. Man, I'm not sure how I pulled that off. I'm not even going to attempt to explain what I think Sansui was doing here. But this is very, very atypical, and it's atypical for Sansui to do this. So what they did is they kind of kludged some stuff across the bottom of the board here, cut some paths. A lot of this stuff was my kludgings, me changing things around in the circuit, but I'm just going to kind of focus on right here. Viewing these boards is a very, very difficult thing because of reflections from the PC board, and it's very hard to get onto camera. It doesn't matter which way you put this damn thing. Oftentimes on YouTube, I found myself that if I'm trying to look for a certain part of a video or something, generally they fly by and the maker of the video didn't show something exactly the way I needed it to be. Sometimes you can freeze images and blow things up. So these are all 220 ohm resistors here. Schematic says that these are half watt, but I mean, honestly, if you ask me, I would say these are probably 1 watts. So I'm not sure what that discrepancy is there. So there's 100 ohm there as well. So Sansui torched these paths off here. These resistors here are connected to the emitters of the driver transistors. This is actually the output line here going out to the binding post. There's actually a relay in series with the audio output on this unit here, but originally the audio output was made by pressing the power switch. That would connect to speakers. But like I said, my unit's modified with a time delay to pull in the speakers on it. So what I'm getting at is typically you should be able to see continuity here to an output, but since there's a switch or a relay in there, you will not see that continuity. So this is an output, this is an output of the other channel. Just kind of looking at the schematic here on my phone, these two here, connection points, are actually going back to the emitters of the driver transistors. The driver transistors are TR13, TR15, TR14, and TR16. So these points right here are actually connected to the emitters of the driver transistors. Those points there as well. They also connect to the base of the output transistors themselves. And we can verify that because these are BCE from left to right. So if we look right here, we see that this resistor leg comes over and does in fact hit the base of the output transistor. This one here does wrap around and hit the base of the output transistor there. Over here, I'm not sure if there's a jumper on top of the board or what, but this does not wrap around to the base, at least what we can see on the bottom of the board. But I guarantee it is. This one as well does not wrap around to the base over here on this transistor, so there must be jumpers on top of the board to connect them. So if you want to find yourself some 220 ohm resistors and put these resistors back in, make sure that you use metal oxide resistors in case they need to burn open. Definitely don't use wire wounds or metal films or anything like that. This one here, as I stated, I just can't quite figure out what this modification was. I'm assuming that the amplifier that you have has these paths cut. This path here and this path over there. Wouldn't make sense that you had something that they were not. So all this other BS up here is modifications that I had made, so you don't need to worry about anything like that, because these were actually changing the frequency response on the differential pair with this resistor and this chip cap there. This was setting a constant voltage on the differential pair. That was a modification I had done. And these are the current limiting resistors for those Zener diodes. This stuff back here was just bleeder resistors that were changed when I changed the power supply around. So that's what that kind of stuff is. That's probably going to be about the best detail that I could really give anyone on this board in order to put those resistors on there. Probably be about right there. You should be able to see the traces well enough. So I'm not quite sure what the symptoms were not having those resistors on there. If it was blowing up, popping output transistors, smoking. You know, I really can't say what the result of that would have been if you were having problems with it going into thermal runaway. Your comment did say that the bias was increasing, and I'm not quite sure about that, why your bias current would be increasing. I mean, it will increase when the temperature of the transistors go up that are on the heat sink here. So I'm not sure how much the bias current was increasing, but I guess it really doesn't matter regardless. You need to get those resistors on the back of the board, and you need to make sure that these are 1K pots here. I think you mentioned in your comment that you had 470 ohm pots in there. And then measure your bias current across these resistors here. Like I said in my video a couple years ago, I pulled these emitter leads up and epoxied them to the side there. That way it gives you two easy test points to connect your meter across to set the bias current. I think in this unit here, you will need 4 millivolts across here and 4 millivolts across here, which would be, not that it really matters, I is equal to E over R. So 4 millivolts divided by 0.33 ohms, that's 12.1 milliamps. Just looking at the service manual here, for this adjustment, run the unit for more than 5 minutes after the power is switched on. And of course, volume is at 0. The temperature range is 65 to 83 degrees Fahrenheit. So when you hang a voltmeter across here, a millivoltmeter, and turn this on, if the unit's working, after about 2 or 3 minutes elapse, you're going to see that creep up very, very slowly, and it should creep up to 4 millivolts. The setting here on these pots to adjust that, make sure when you put pots in, make sure you turn the things fully counterclockwise. I know that sounds stupid, but you know, I do dumb things myself too sometimes. Make sure that you turn those fully counterclockwise before you power it up, because I haven't verified that with these pots fully clockwise that the unit would not draw so much current that maybe something would go bad. I haven't verified that in this unit. But as long as you have, you know, the proper transistors in it, that would never happen. They're usually very, very good when they select these bias pots to make sure that, you know, if you don't have it fully counterclockwise when you start it up, it's not drawing excessive current to the point at which something would pop or go bad on you. And I'm just kind of looking at my pots here, and you can kind of see an arrow shape there. Surprisingly, you can see how far that arrow is turned up there. The whole way over here towards this leg would be counterclockwise, and you can actually see the arrow is facing this way. So that pot is more than halfway up. And I know that when I set bias on this, it was like 3 or 4 millivolts drop across there. So all you really want to do is, just check it after 5 minutes. Put your voltmeter on there, as I said, power this up, write down what your voltage drop there is in millivolts, which will probably be down around 1 or 2 millivolts when you first turn it on, if even that. And then after 5 minutes, you want this to shoot up to 4 millivolts. Beyond a 5-minute period of time, don't pay no attention to anything. It's basically a dead-end adjustment. You just wait 5 minutes, adjust it to that value, and then kind of call it quits. What you can do is let the unit go back to room temperature, because these are very, very sensitive. When there's just the smallest amount of current flowing, there will be a very, very small heating effect. So before you go back and double check the bias, let it go back to room temperature again, and then power it up, and then verify once again that after 5 minutes, this creeps up to 4 millivolts. And beyond that, I mean, don't worry about it. If the unit's hot, if the unit has been run, the bias current won't be 4 millivolts. What's important is to check it from a room cold or from a room temperature to the 5-minute mark. Once you run these units and this heatsink comes up to temperature, the beta on the transistors are going to increase, so you're going to have more current flow. If you tried to go back and remeasure what the bias current is, it's going to be higher. Now, the bias current should not run away on you. Also, at the same time, running this unit should not allow the bias current to escalate to a point at which the transistors go into thermal runaway or end up self-destructing on you. If that's the case, and if that's something you experienced at some point in time, well, then there's something else wrong, because that should never happen. Now, also, I will say this, not that this has anything to do with anything, but these transistors here are not original. The beta of these transistors, if I were betting on it, I would say the beta of these transistors is 100, very, very closely to 100 anyway. Originally, this unit had TO220 transistors in it. I put TO3Ps in here, and I still didn't have any problem with this bias pot not being able to set this unit properly. Just FYI, and I'm sure it really goes without saying, and I'm sure you know this, that if you put transistors in it that have a higher beta than what the original transistors were, this pot's going to go more towards the counterclockwise direction to try to hold those transistors out of conduction. I think when sansui spec this amplifier, if it's typical with all other sansuis, generally they refer to Y betas. Let me just see if I can confirm that on the schematic. They're saying O or Y betas. So with an O beta, and I could be a little bit off here, I think that's going to be a beta range of about 80. It might be a little bit lower than 80. And it's been a while since I've had to think of this. The Y betas are the highest betas as far as current gain on a transistor goes. And typical Y betas are about 100. But I think Y beta does carry up to probably like 120, 140 on the current gain. The O betas are lower. They're a mid-range current gain transistor, and I want to say they're probably around 70 or 80. I could be a little bit off on that. So, that relates back to where this pot's going to be set. The higher the beta, the lower this is going to be set. Y's being the higher gain, O's being the middle gain as far as current gain on the transistor. So enough about that. Hopefully this tells you what you need to know to get those resistors back on the back side of the board. If you have any more problems, let me know. If there's anything I can do to help you, get this Sansui a-40 going. It's a cool little amp. It's a bare bones amp. I think what Sansui was going for here when they made this, kind of joking a little bit, but Techniques came out with a slogan many years ago that said that the best amplifier is a piece of wire with gain to it. You know, I think what they did is the engineer said, I have 8 transistors here, and I just want to see if I can make an audio amp out of this. And that's what he did. There's nothing to it. It's kind of a miracle that it is an amplifier, but it definitely has those bases covered. 8 transistors, I think it is, per channel if you count the 2 for the differential pair. Yeah, maybe it was 7 transistors per channel. But that's kind of an engineering feat either way, 7 or 8. Thanks for watching. Have a good day.